Okay, so today we'll be talking about stacks. Stacks. A stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real-world stack. For example, a deck of cards or a pile of plates, etc. A real-world stack allows operations at one end only. For example, we can place or remove a card or plate from the top of the stack only. Likewise, stack ADT or that's stack abstract data type allows all data operations at one end only at any given time. We can only access the top element of a stack. This feature makes it LIFO or last in, first out data structure. So again, LIFO stands for last in, first out. Here, the element which is placed or inserted or added last is accessed first. In stack terminology, insertion operation is called push operation and removal operation is called pop operation. Stack's representation. A stack can be implemented by means of an array or an instruction, pointer, and linked list. Stack can either be fixed size or it may have a sense of dynamic resizing. For this lesson or for this chapter or for this video, we're going to implement stack using arrays, which makes it a fixed size stack implementation. So again, if we're going to look at this image, this is how we can view the stack. We push stack at the top and we pop only the top element. So push on on this portion only, and again the operation is only done on the top, and we pop off only the top element. So this is how a stack operates. So basic operations. Stack operations may involve initializing the stack, using it, and then deinitializing it. Apart from these basic steps, a stack is used for the following two primary operations. So these are the push and pop. Push is for pushing is also storing an element on the stack. So again, if we push, we store an element on the stack, or we add an element to the stack, or we insert an element to the stack. Pop is removing or accessing an element from the stack. So we access it, and at the same time, we remove the element from the stack. When data is pushed onto a stack, so to use a stack efficiently, we need to check the status of the stack as well. For the same purpose, the following functionality is added to stacks. So peek is to get the top data element of the stack without removing it. So we can view or we can access the top element but without removing it. Isfull is a function that will check if the stack is already full. Isempty, so again, it's a function that checks if the stack is empty. At all times, we maintain a pointer to the last pushed data on the stack. As this pointer always represents the top of the stack, hence we name it top. The top pointer provides the value of the stack without actually removing it. So let's try to discuss some of the functions. So pick, again pick will get the top data element of the stack without removing it. So the algorithm for that is, so begin the procedure pick, we just return that element where the top is pointing or with the index top. And that's it. So in C language, if you're going to implement that in C language, integer pick, assuming that the stack is a stack of an integer, so integer pick, so return stack with the index of top. So this is using an array implementation of stack. Isfull. So the algorithm is full function. So begin procedure is full. if top equals to max size, so if the value top is equivalent to the max size, then return true. That means it is already full. If not, then return false. That means that the stack is not yet full. So let's try to look at the implementation of isfull function in C language. So Boolean is full, so it returns true or false, or we can also have this as an integer. So, but since we use Boolean, so Boolean is full. If top is equal to max size, that's the maximum size of the stack, and the top value are equal, then that means that the stack is already full, so we return a true value. Else, then we return a false value. So this function returns a false value. It's empty. So we also have to detect if the stack is empty. So the algorithm is procedure is empty if top is less than 1. So again, the index of an array is from 0. So if the top is less than 1, then that means that the array is empty. So we return true for the isempty function if top is less than 1. Otherwise, we return false. So implementation of this empty function in C language is slightly different. We initialize the top at -1 as the index in the array starts from 0. So we check if the top is below 0 or -1 to determine if the stack is empty. So here's the code. So again, Boolean is empty. If top is equal to -1, we return true, else we return false. So that's our C language implementation. Then the push operation. So let's now go to the main operations of stacks. So the push operation. So the process of putting a new data element onto a stack is known as a push operation. Push operation involves a series of steps. So the first step is to check if the stack is full. So why? Because if the stack is full, then we should not be uh, storing element inside the stack anymore. So if the stack is full, produce an error and exit. If the stack is not full, then increment top to point next empty space. So we increase the value of our top index. So it should be pointing now to the next empty space. Then add data element to the stack location. So where top is pointing. So whatever values, whatever is the value of the top, then we should be adding an element to that stack location. And then we just return an indicator that the push operation was successful. So just like here, initially top is pointing to D. So if we're going to add an element, we increase the value of top and then we place the element on that portion where the top is uh, pointing. So that is how this is more the visual presentation of what we have discussed a while ago or on the previous slide. If the linked list is used to implement the stack, then in step 3, we need to allocate space dynamically. So what if we're using linked list rather than array? So if to create a new value, we have to create or allocate space dynamically. So using malloc function. So here is now the algorithm for push operation. So again, we test if the stack is full. If the stack is full, return null. That means it was not successful. Then if not, go to the next value of top. So top plus 1. And then the data will be stored in that portion of the stack. So that's the algorithm, the pseudocode. So let's try to look now at the C language implementation. So we have to void push integer data, assuming that the data is equal to the element of the stack. So if not is full, so if it is not full, so we just reverse that one. Then we do the operation, we do the push operation. So top is equal to top plus 1. You move the top index or top pointer to the next space. And then we now store the data to that portion where top is now pointing. So that's the new location. So otherwise, if this function is not true, that means it is full. So we just print a message that will tell the user that you could not insert any more data because the stack is full. Then let's now discuss the pop operation. Accessing the content while removing it from the stack is known as a pop operation. So in contrast with the pick, so in the pick we can access the element, but we are not going to remove the element from the stack. So in an array implementation of pop operation, the data element is not actually removed. Instead, the top is just decremented to a lower position in the stack to point to the next value. But in a linked list implementation, pop actually removes data element and reallocates memory space. So we can do that if we're using a linked list. So a pop operation may involve the following steps. So these are the usual steps in a pop operation. The step one is to check if the stack is empty, because we should no longer pop if it is empty. Then step two, if the stack is empty, then produce an error and exit. So we don't need to pop anymore because it is already empty. But if it is not empty, then step three, access the data element at which the stack is pointing. So we have now accessed that element, and then we move our tab to the previous position, or we decrease the value tab by 1, and then we return success. So let's take a look at, let's explain that again visually. So you can see here that tab is pointing to this. So that means it is not empty. Since it is not empty, we access this value and we move tab to the previous element. So it is previously pointing here, then now it is now pointing to the previous element. And we, as if we have removed, or we remove the top element from the stack, the pop. So let's take a look at the code. So pop stack, if stack is empty, we return null because we don't need to pop again if it's empty. Then we get the data, so we get the data from the top of the stack. Then we move to the previous value stack, or we decrease the top, the index tab by 1, then return data. So in C language, so integer pop if data, so this function returns an integer because we assume that uh, our stack contains integer. However, if your stack contains other data type, then you should replace this one. So in data, so if is empty, if not is empty, so if it's not empty, then uh, the element at the top of the stack is stored on this variable data, and then we decrease the value top, then we return the data. So as if we have removed the element at the top of the stack. So otherwise, if it's not empty, or if it is already empty, rather, then we just print a message saying that it could not retrieve data, stack is empty. So that is now the stack operation. Now let's try to view the source code C language program. So in this program, we have just declared a maximum size of 8. So we declared an array with an 8 elements. So top again initially should be -1 because 0 is uh, the lowest index in an array. So we have -1. Again, we already have discussed is empty. We already have discussed school peak. So peak again returns the top element without removing it. So pop, we remove the element at the top, but we also return the data. Then push, we push the data on the top element. So we have already discussed all of the functions. So here in this demo, we're going to push 3, 5, 9, 1, 12, 15 in this sequence. So, and then this will print the element at the top of the stack. So if we go to view this one, it should be printing 15 because the last one that we push should be the first one to pop. Or if we pick again, it should also be the last one. But again, in picking, we don't remove the element. The elements are, so what if we do here? We just have a loop until our stack is empty. Okay, so if it is not empty, we pop and then we just store the value at the top to data, and then on the next time you print the data. So in other words, we just try to print all of the elements in the stack. So again, since it is last in, first out, then we're expecting that 15 will be printed first, followed by 12, 1, 9, 5, and 3. So that will be printed here. Then after that, since we have popped all of the elements until it is empty, so stack full is full, then this should be equal to false. Stack empty, then this should be equal to true. So why? Again, because we have popped all of the elements of the stack. So let's try to run the program. Execute, compile and run. So here we can see here now that element at the top, the stack is 15. So elements, again, so 15, 12, 1, 9, 5, 3. So it's in the reverse order. So stack full is false, stack empty is true. Okay, so that's all for this video presentation.